well. But to start off with, before we do that, we need to look into what we know as the IUPAC rules. And so these are the rules for naming organic compounds and basically just for understanding the structure and how that affects the name of any organic compound. So these are our main 4 rules which we have, and then we also have some supplementary rules to assist in making the naming of these a bit more coherent. So our first step in naming any organic compound is that we need to identify what the parent chain is. And so the parent chain is going to be whatever the longest carbon chain is that's present in the molecule. So whether that be 5 carbons long, making it a pent molecule, or 10 carbons long, making it a dec molecule, or 2 carbons long, making it a an F molecule. So that's just looking back at our original naming of the alkanes, so the methane, ethane, propane, butane, pentane, continuing on. And so that will determine generally what the prefix is going to be for the molecule. The second step is that you need to recognize and correctly prioritize what the functional groups are that are present. So we'll look more into the prioritizing a bit later, but recognizing what the functional groups are that are present is very important. So that's looking along the molecule and identifying, do we have a hydroxyl group, or do we have a carboxyl group, or a carbonyl group, or is there nitrogen in this molecule also coupled with a carbonyl group, which may make it an amide as opposed to an amine. And so it's really just identifying what functional groups are present and so what class of molecule you believe this may fit into. And then prioritizing them would be determining, well, if they also have say for example, if they were to have an halogen group and then they were to also have an amide group, which one's most important in giving the suffix for the name, and so which one's most important in our naming conventions, and would that make us consider this an amide or a haloalkane molecule in preference. And so in that case, obviously an amide is a lot more substantial, has a lot more impact than a halogen in a molecule, so obviously the amide would take priority over the halogen in that particular circumstance. The next thing we want to look at is the number of carbons on the chain. And so this is something that's done directionally. So the lowest number is going to be given to the carbon with the highest priority functional group. So this is saying that when we count along the chain, we're going to want to count from the end with the highest priority functional group. So if our highest priority functional group is on the right-hand side, we count the right-hand side as being 1, 2, 3, 4, etc., etc. We'd have to count from right to left. If our highest priority functional group was on the left-hand side, we'd have to count from left to right because we want to number our functional group so that it's at the lowest possible number. But if we have functional groups on the opposite ends of the molecules, we need to determine which one's the highest priority. And so hence the one with the highest priority will be the one which will be named with the lowest number. The final step is adjusting the name based on branches or functional groups that are present, and this is done by listing their prefixes in alphabetical order with numbers. So we list the functional groups out the front that may be prefixes, and those prefixes will always need to be put in alphabetical order with numbering at the beginning. So if it's on the first carbon, for example, if we have a methyl group on the first carbon, we would have to name it, on the second carbon, we'd have to name it 2-methyl and then the rest of the chain. If we had a methyl group and an ethyl group, as we're naming them in alphabetical order, we have to put the ethyl group before the methyl group as they would be named in alphabetical order. Something also important to note with these is that if we were to have 2 ethyl groups, hence if it was to be diethyl, that would still put ethyl, or dimethyl, that would still put methyl ahead of ethyl. So if we had dimethyl, that would still put ethyl ahead of methyl, because if we were to have an ethyl group and 2 methyl groups, it would still go ethyl dimethyl, even though the dimethyl is making the alphabetical order switch the other way around, because we're just looking at the actual part of the prefix, not the multiplier of the prefix. So now we can look at some of our supplementary IUPAC rules. And so this is talking about extra rules which help in making the naming a bit more clear. So if we have more than one side chain or functional group, we need to add a prefix which relates to the number of them. So as I was previously talking about before, we can use, if there's 2 of a particular functional group, we have to use di, 3, tri, tetra, 4, etc. And just depending on how many there are of that particular functional group, and then list all the numbers of where they are located. So if you were to have a methyl group on the 2nd carbon and a methyl group on the 3rd carbon, you'd have to say that it's a 2,3 dimethyl at the beginning. And so you don't count the prefixes when figuring out the alphabetical order. So as I said before, if you had an ethyl group but then a dimethyl group, you'd still put ethyl before dimethyl, even though alphabetically that wouldn't seem right, because ethyl comes before methyl in the alphabet. The next thing we need to note is that you use commas between numbers. So for example, if we're saying that we've got a methyl group on the 2nd carbon and a methyl group on the 3rd carbon, you'd have to say 2, 3 hyphen dimethyl. So that also leads to the next point, which is using a hyphen between letters and numbers. So anywhere where you separate the numbers from the letters, you're going to have to put a hyphen. So if you're saying that there is a chlorine group on the 2nd carbon, you'd have to call it 2 hyphen chloro, whatever the rest of the chain is. It's also important not to put spaces between prefixes. So if you have a prefix ahead of a particular molecule, so for example, you had a methyl pentane molecule and it was on the 2nd carbon, it would be 2 hyphen methyl pentane. Methyl pentane would not have a space in between it, it would just be methyl pentane being one word. Then when we're looking at double and triple bonds, that being alkenes and alkynes, the number which has to be used to name where the double or triple bond is located is going to be the lower number out of the 2 carbons that the bond is between. So for example, if the double bond is between the 1st and 2nd carbon, you would name it as it being between the 1st carbon. If it was between the 4th and the 5th carbon, you'd say it's at the 4th carbon. If it was between the 2nd and the 3rd, you'd say that's at the 2nd carbon. So it's always going to be the lowest number between the 2 carbons. The next important thing to note is that if the functional group could not be on any other possible carbon, don't write the number. So for example, if we're talking about an ethane molecule and we're saying that there's a double bond between, and we're changing that into an ethene molecule, so we're putting a double bond between the 2 carbons, which there are. Obviously the double bond, if there's only 2 carbons, the double bond can only be between those 2 carbons, so hence we would just call it an ethene molecule. We wouldn't have to call it one ethene. And finally, the branch is going to be the same way, it's going to be named the same way that a separate molecule with that structure would be named, but with the suffix "il" instead of "ane." So for example, if you have a branch which has 3 carbons, so a 3-carbon branch coming off a normal carbon molecule, it would be a propyl group because it's like propane, but it's a branch coming off another chain, so it would be named as a propyl group. So if you had a carbon molecule which is 10 carbons long, but on the on like the 5th carbon in, you've got a branch with 3 carbons on it, you call it 5-propyl decane to show that it's got 10 carbons along the main backbone, but on the 5th carbon in, there is a branch which is 3 carbons long. So now we'll just look at a bit of a summary of the functional groups and particular prefixes and suffixes which can be used for these. So when we look at our functional groups, when we look at the first one, we can see we've got a carboxyl group. And so generally with carboxyl groups, we'll be using the suffix of oic acid. However, in this case, in some cases, we will be using the prefix of carboxy, and so that really just depends on the prioritization of a particular functional group. So whether that is a low priority functional group, and hence we might have to use the prefix, but generally we'd be using the suffix of oic acid. With amides, generally the suffix will be amide. However, sometimes the prefix of carbamoyl or amido is used, and so that's just obviously the prefix will be used typically if it is a lower priority functional group. Same with nitriles, we're typically using the suffix of nitrile. However, sometimes the prefix of cyano is used for when it's a lower priority functional group. Aldehydes, we're typically using the suffix of al, but sometimes we may use the prefix of oxo, and same with ketones, they may also sometimes get the prefix of oxo, but typically they'll be using the suffix of -one, which is generally a lot more reliable to use the suffix of -one because it really denotes between aldehydes and ketones, because the suffix shows that they're a different class of organic compound, whereas the prefix doesn't show that very explicitly. For the hydroxyl functional groups, so for alcohol molecules, we're typically using the suffix of -ol. However, there's lots of complex alcohol molecules, and so the prefix of hydroxy is actually used quite commonly when alcohols and the hydroxyl group is a lower priority functional group, and that's just because there's lots of very, very complex molecules that have alcohol groups or hydroxyl groups in them, and so hence the hydroxy prefix gets used quite frequently, but typically you would want to preference using the suffix of -ol just because that's your normal naming convention for an alcohol. So unless there's a higher priority functional group, you wouldn't want to use the prefix of hydroxy. The next one is amines, and so typically they'll just have their suffix of amine. However, these ones also do have this thing similar with alcohols where they are involved in very complex molecules sometimes, and so the prefix of amino is also quite common as well. That's one which is used sometimes, but generally in this syllabus in particular you'll be focusing on using the suffix of amine. Next we've got alkenes. So alkenes typically will have the suffix of -ene. However, sometimes you'll have those prefixes of alkenyl. So that being typically if there's a branch coming off the molecule, they'll have the alkenyl prefix. Same with alkynes, they normally have their suffix of -ine, but typically if there's a branch, they'll use the prefix of alkenyl.